In addition to deploy EKS worker nodes using Amazon Linux, you can also use another OS called Bottlerocket. In this lesson, I'll teach you what is Bottlerocket OS, why we need it, and how we can deploy EKS worker nodes using Bottlerocket OS, as well as how we can deploy and use its update operator to automate worker node upgrading process. Let's get started. If you didn't join our social media, please follow our LinkedIn page, Twitter, Facebook, Telegram, as well as our YouTube channel. So, what is Bottlerocket OS? Bottlerocket OS is a Linux-based operating system developed by AWS community, and it's designed for containers and Kubernetes environments. Think just like other general purposes OS that you can use for everything, but Bottlerocket OS is specifically designed for containers. If you search for Bottlerocket, you can find some information and the use cases along with success stories in AWS, which provides you lots of information, and other companies right now they are using Bottlerocket OS in their non-prod or prod environments. And if you check its official website, it provides you tons of information. Bottlerocket has three primary goals: to be minimal, with safe updates, and security-focused operating system. In the case of minimal goal, for each platform, for each orchestrator, and for each architecture and Bottlerocket version, it provides different image that make it easy to use, and it's minimal to be deployed into your instances and environments. Bottlerocket comes with only required and necessary set of tools, binaries, and package to deploy containers and nothing else. And because of that, it's really, really small and minimal. In the case of accessing Bottlerocket OS, the host system, is not just like other general purposes Linux systems like Amazon Linux, Ubuntu, Red Hat, Fedora, or any other general purposes operating systems. Because when you install something like Amazon Linux or Ubuntu, and you want to deploy your container on top of that host OS, you connect directly through the SSH or any other communication way to the main OS, the host OS, and on top of that, you can find all the containers because you are in the main and the first Linux namespaces, and those namespaces are the parent of the others, and because of that, you can find and see all the other processes in a child namespaces. But in the case of Bottlerocket, it deploys another container called host container in addition to your normal container, the application containers. That container is a privileged container, and you run the shell inside the host container. So it's completely isolated from your application container, your normal workload containers. And when you want to communicate with the Bottlerocket OS, it means you connect into that isolated environment, into that isolated container. And if something goes wrong within that container, it has nothing to do with other containers. So you're safe. In the case of safe updates, because the system is designed on top of image and normal container image, Bottlerocket doesn't have any package manager like apt, yum, or any other package manager. Instead, when you want to update the OS, it means you need to pull the new image, and after upgrading the system and restarting the system, instead of running the old image, it runs the new version automatically. And it makes your update safe. And in the case of security, it comes with the immutable root FS. It's not just like Amazon Linux or Ubuntu that you can change and alter your root FS at a runtime. In a Bottlerocket OS, no one can touch or change or alter the root FS at runtime. And in addition to that, because it comes with container image, it's signed with some cryptographic algorithms. And it's protected to block level. And when you update the system or you want to change the root FS, it means your system should be restarted. And after the restarting the system, the whole image gets changed. The main image gets changed. And it means it will be replaced automatically. This is something about Bottlerocket OS you need to know, and it's good to know when you want to work with logs, image, and configuration. All of them persist per file basis in your environment, and if you add some policies, it cannot be altered after that. Check bottlerocket.dev website to get some information, AWS and its official GitHub repo to find more information about what is Bottlerocket OS. But keep in mind, it's a really good and minimal operating system designed for Kubernetes environments to run your container, pods, and workloads. So why we need Bottlerocket OS for our Kubernetes environment? Bottlerocket is an open source operating system built for containers. It's optimized for running containers within Kubernetes clusters. It has less overhead compared to general purpose operating system because it comes with fewer tools, libraries, and binaries. And in addition to providing less overhead, it means you will face with fewer security issues and pitfalls. And the good thing about Bottlerocket OS is it supports Kubernetes-based in-place upgrades using its update operator. So you can update your worker node within Kubernetes environment with your Kubernetes using standard Kubernetes operators. And it's fully integrated with AWS EKS cluster and EKS platform. To deploy Bottlerocket, you can use and choose previous methods I mentioned for deploying EKS worker nodes. You can use fully managed node groups. You can also use custom launch template. And of course, you can use self-managed worker nodes method to deploy your worker nodes using Bottlerocket OS. It's just like deploying worker nodes using Amazon Linux, but right now we want to use another operating system. So in this lab, I want to use fully managed node group because it's easy and we can focus on some specific things related to Bottlerocket OS. So let me check our cluster first. We have a cluster here, and now we have no any node groups. I want to deploy a new node group for system critical applications. And as you can see, instead of using Amazon Linux version 2, I want to use Bottlerocket OS. And another important thing is to add a new label to our node, because After deploying our worker nodes, we want to install its update operator. And to be able to mark our worker nodes that are using Bottlerocket OS, we need to add some specific labels to be managed by Bottlerocket update operator. So keep in mind, you need to add a new label, because in the next step, I need that label to mark our worker nodes that deployed using Bottlerocket OS to be managed by its update operator. In addition to node group for system critical workloads, we can deploy another one for our applications, and after some time you can find that worker nodes are ready to use, because the image is small, and as you can see, it's get deployed. The system worker nodes, the system critical worker nodes get deployed because the image is small and you can install it just in click. And now if we check from the cluster, update kubeconfig for kubedemi cluster, and now check the nodes, and as you can see, our system critical worker nodes are ready, and after some time, in less than a minute, you can find that your worker nodes will be ready. So we have our Bottlerocket OS nodes, and if we check in EC2 dashboard, yeah, it's started, and now our worker nodes are ready. So to test, we can create a deployment, nginx, and replicas, for example, 2, and get pod. And after pulling nginx image, you can find that it works nice and easy. Now we have our cluster, we have our worker node. It's time to deploy its update operator to automate worker nodes upgrading process within Kubernetes environment. By installing Bottlerocket update operator, you can update your worker nodes with your Kubernetes cluster. It means when the new update is available, it automatically get the new image for Bottlerocket OS. It's drain the node to move and push currently running application and containers on that worker node to another worker node, and restarting your worker node to be to deploy and to run the new OS image. And after that, the system is ready to use. So to deploy that, you can follow these instructions. First, we need to install Cert Manager to create some certificates for Bottlerocket OS update operator. Okay. We have to wait for Cert Manager operator to be deployed into our Kubernetes cluster, and after it's up and running, we can install Bottlerocket update operator. Cert Manager, get pod, all up and running, and now it's time to deploy Bottlerocket update operator. You can install it using its manifest, and you can also install Bottlerocket using Helm, but I faced with some issue when I tried to install its Helm chart, and I have to spend some time to fix it and creating a pull request to fix the issue for the world. So let me just install it using the raw manifest. And now if you check your namespaces, the namespace is created, and if we check what we have within this namespace, you can see we have its controller, the API server, and now we have to install the agents. After some time, you can find that it deploy the agent, but how we can mention in which node we want to install the agent is by marking our Bottlerocket worker nodes. To do that, we have to use this command to add this label to our worker node using that are right now they are using Bottlerocket OS. So let me run this command, and as soon as you apply this label to your worker nodes, if you check, you can find some agent is coming up with its update operator. It's update operator agent. And now, as you can see, we have 4 nodes, but we have 2 agents, which means in somewhere we have some issue. And the issue is our system critical worker nodes are changed, and we have to tolerate its agent to be able to tolerate and bypass our chains to deploy agents to our system critical worker nodes as well. To do that, you can run this command to patch its daemon set, and as soon as you do it, you can find that the agent, the new agent, will come up, and after some time it should be ready. Okay, anyway, in the meantime, I want to show you something else that's related to its use case. Yeah, it's coming up. If you patch the daemon set first, and after that adding label to your worker nodes, you don't face with such an issue, because right now we marked our worker nodes, and the daemon set controller deployed 2 agents. After that, we changed the configuration of our daemon set, and it means the old part should be removed from the system, from the worker node, and the new one should be deployed. And because of that, it deploys the agent first and then remove it and redeploy it again because of changing the configuration in our daemon set. And right now, everything is up and running. And if you run this command, You can see it provides you the new version and it provides you the current version. Right now there is no any view version because we deployed the latest version, but as soon as it finds a new version, it provides you the information, and in the best time it drains the node and upgrading your worker node and automatically restart Bottlerocket worker nodes. The other thing I want to mention, if you check its launch template, you can find that the user data is a bit different with what we use for our custom launch template. It's not like shell, it's not like bash script or something like that, because it uses its own specific configuration, and and you can find that there is some variables you need to provide, and that's it. And as soon as the new image come up and running, it reads this information and it join your worker node to your Kubernetes cluster, your EKS cluster. And another thing, the good thing about the Bottlerocket is it's not just for EKS. You can run Bottlerocket for other environments, and you can find it here. It's available for AWS, but is also available for bare metal and other cloud environments that you can use Bottlerocket OS for your environment. And we have the thing, and it's time to discuss about is Bottlerocket is ready for production environments or not. Bottlerocket is a 3-year-old OS for containers, and it's really too early to tell that it's ready for production environment. But the thing is, you can find some success stories in AWS website, which provides you tons of information to make the decision if you want to run Bottlerocket OS in your production environment for your production workloads, or if you want to run Bottlerocket for your non-prod and dev environments, and after it's being ready for production, then you can deploy it into your production environments.